Thank you. Yeah, so I probably don't need to introduce myself, but yeah, I'm Rob Hawkes. So I'm basically just here to talk to you a little bit about HTML5 games and some of the technologies involved in their creation. So it's already been mentioned, but yeah, I work at Mozilla as a technical evangelist. So the same guys who make Firefox. Who here doesn't know that Mozilla is a non-profit? Okay. And no one brave enough? Okay. Usually it's about half, so that's interesting. But yeah, I'm pretty fond of Mozilla, so my girlfriend actually made me this chicken and leek pie with the Firefox logo on it. So she's pretty forgiving for me, so yeah, it was nice. So I'm not too sure how long we'll have for questions at the end. I'm going to sort of pack this out. But feel free to grab me after this on Twitter, or just grab me like in the evening later on. And also these slides will go online as well, so all the links and everything I talk about will be in there. So lots of detail, so don't feel like you need to write anything down. So I think it's safe to say that games are pretty important, and that's for many, many reasons. One of those is that games are universal. So there's games out there to suit all walks of life, whether that's board games, card games, or computer games, it's all the same. So over the years, as I imagine with you guys as well, I've played all sorts of games that sort of mean something to me at various points in my life. So one of these would be like Paperboy on the ZX Spectrum, way back in the day of the cassettes and stuff like that. And I sorely miss those like loading sort of noises and stuff, as it sort of took ages to sort of come onto the screen. And then things like Bomberman on the SNES, like that was one of the first games that really got me addicted to gaming. And also one of my favorites, like Lilac Wars on the N64. I think it was called Star Fox for outside of Europe. So has anyone played Lilac Wars? Star Fox, okay. That's not many. And then like throughout that sort of console period, I was playing things like PC games. So like the original SimCity. I don't dare think the amount of hours I lost to that silly game, but it was great fun. And I only just realized it's really muddy in that sort of that city. Did anyone play the original SimCity? Wow, okay, pretty much everyone, that's pretty cool. And then also things like Red Alert, like the Command & Conquer series is absolutely fantastic. It's probably one of my all-time favorite games as well, so it's just absolutely fun. And it had an amazing soundtrack as well. But yeah, I mean, my point here is sort of games are sort of damn fun, really. And this is probably because they tap into our addictive sort of competitive personalities. I think everyone likes playing some sort of game. I don't really know anyone who actually hates games. Is anyone brave enough to say they hate games? Okay, good. That would have been weird. But I do know people who hate fruit. So one of my favorite games at the moment is Fruit Ninja on the Kinect. Has anyone played that game? A couple people. Okay, the rest of you, you're missing out, and I'm going to show you a little bit of it. It pretty much justifies the Kinect's existence. So I had a few friends over, actually, a few weekends ago. And we all came out of that weekend with Kinect Fruit Ninja-related injuries. But it was totally worth it. So yeah, I'm just going to sort of show you a quick little demo of it, because it's absolutely hilarious. So it's basically just you just flying around, and you get that pomegranate at the end, you just got to go crazy, and it just goes on for as long as you want. So it's absolutely hilarious, and you just get sort of screwed up arms and all sorts of stuff. And you can do two-player as well, so you sort of hit people as well. It's good fun. But yeah, so the other sort of aspect of games which is interesting is that they push boundaries, and this is really important from a technological point of view. They basically push the technology as far as possible. So they're one of the only things that really deliberately use every ounce of the computer that's available. So from graphics to processing power to the memory to disk space. And as computers get better, games improve to use up these new improvements in computers. And as computer hardware is, computer hardware is improved, mainly to sort of allow for better games to be created, more realistic games, all that kind of stuff. So one example recently is Battlefield 3. So this was launched late 2011. Does anyone here play Battlefield 3? Okay, there's barely anyone. That's interesting. Maybe it's not that big over here. So this came out in 2011. As you can see, it's pretty realistic. That's a screenshot from the game. That's actually what it looks like. So if you compare that to Battlefield 1942, which is only from 2002, so that's 9 years difference. And if you can completely see the difference, I mean, the quality of the graphics and the textures and all that kind of stuff, it's just absolutely appalling. But that was a high-quality game back in the day, and this is a high-quality game now. And then when you compare like the minimum specifications of those two games, so 9 years difference, remember, and we've pushed computers so far that the minimum requirements for Battlefield 3 are just way, way beyond what was even possible back in 2002. And that's just minimum. And if you want to get something that actually looked anything like that screenshot you just saw, you're going to need like the recommended specs, or even the sort of further than that. And the red bar there is the recommended specs of Battlefield 3, which is double the minimum. So it's just incredibly sort of powerful, the kind of computers that you need right now. And this is kind of normal. So the other thing is this improvement with technologies and with games sort of it means a better web. So the improvement that games bring about in the technologies on and computer hardware mean we can do some really, really cool stuff on the web. So without games, there'd be little sort of need to push browsers as much as we do at the moment. So things like faster JavaScript or accelerated CSS and multimedia rendering, all that kind of stuff, is partly coming about because of the improvements that games are bringing with technology. So sort of in a long-winded way, I suppose I'm saying that you need to play more games, basically because you're making the web better and you're having fun at the same time. So it's kind of win-win. So by playing games, browsers are getting better at the same time. So let's shift our focus to HTML5 games, because I think that's sort of the point of this talk, really. So I wanted to cover a few HTML5 games that I'm pretty fond of at the moment. Has anyone here knowingly played a HTML5 game yet? Okay, that's a fair amount of you. Okay, so one of my sort of favorites, and this is quite old actually, was a Quake 2 sort of port that a couple of guys at, I think it was at Google, did this. And they open sourced it and all that kind of stuff. And it basically just was a full port of the game with like sound, multiplayer, 3D graphics, all of that kind of stuff. It was fantastic. And it was a really good example of what the technology could do at that point in time. So more recently, we've had sort of ports from mobile sort of operating systems. So from iOS, we have Cut the Rope. So this was a absolutely slick HTML5 demo that, well, not demo, a game that IE worked on, or partnered with at least, to bring this to HTML5. So you can play this today. And then Bejeweled. So has anyone here played Bejeweled? That's good. It's a pretty cool game. So Bejeweled was a game by PopCap, and it was interesting to see what they did with the HTML5 version and how they sort of brought this over to the web. And what a team that have such a sort of high-quality game that sort of doesn't really need much doing to it because they've just been working on it for so long. So it's a very, very slick game, and like you probably saw with the animation there, like there's all these sort of transitions and stuff between the levels, and it's just nicely done. So I mentioned Command & Conquer earlier, and EA are actually working on a HTML5 game called Command & Conquer Tiberium Alliances. So it's sort of in public beta at the moment, so you can actually play it. And this is kind of sort of part real-time strategy, part Farmville. They probably don't describe it like that, but that's sort of what it feels like. And you just build up these bases, but it's an ongoing game in that the original Command & Conquer, you played in one go and that was it. Whereas with this version, it's sort of a little bit like Farmville in that you build up your own base and you've got your friends' bases and stuff, and you can upgrade things. But you play it over periods of days and weeks. It's an ongoing game. And we'll touch on why that's interesting later, actually, the ongoing sort of game stuff. So a 3D game, actually. So GT Racing Motor Academy is a 3D racing game by Gameloft, which was helped by a company called Mandrill, who have this sort of porting software. And I'll sort of mention those briefly at the end as well. So this is a really interesting sort of example of the 3D technologies that are on the web right now. And then there's Browser Quest. So has anyone played Browser Quest? That's pretty good. Okay, it's about half of you. So Browser Quest is a massively multiplayer role-playing game that we worked on at Mozilla. It's basically just a demo of the technologies that sort of are on the web and how they could be used to create a game and whether it was even possible to do sort of massively multiplayer. So I mean, we'll go through the technologies that were created and used to create this later. And the interesting thing with BrowserQuest was it was built to work fantastically on all the platforms that HTML5 are supported on. And it's also open source, so you can go on GitHub, and the links again are in the slides. And you can actually dig through the code and have a look at how this game was created. It's really good fun. So yeah, let's go through some of the technologies involved. So I mean, I showed you some of the demos. You got to see some 2D graphics, 3D graphics, and all that kind of stuff. So 2D graphics is mainly canvas. You can do sort of DOM images and that kind of stuff, but that's fairly obvious, and I'm not going to cover those. I'm going to cover sort of specific APIs. So the Canvas API is a 2D graphics API for bitmap drawing. And it's quite amazing what can be done with such a simple API. It's very much like an Etch-a-Sketch in that you draw something, and then if you want to animate, you sort of erase the whole sort of canvas, and then you draw something again. And if you do that fast enough, you've got an animation. So games use this technology to sort of use like what they call sprites, which is images, and animate them and all that kind of stuff, or that you can actually draw sort of whatever you want on top. So one interesting non-game example of Canvas is Silk, which is basically just using some of the basic, the simplest sort of APIs in Canvas and just layering them up on top of each other. And you end up with a really, really beautiful example of sort of some just graphic visualization. And the APIs behind it are just fairly simple. And you can also use Canvas in other ways. So I suppose you should ask, is anyone using Canvas today? Wow, that's pretty good. That's really good, actually. So this is Close Pixelate, which basically allows you, it's an example of the image manipulation sort of functionality of Canvas. So what you can do with Canvas is you can access images and the pixel data, and then you can pull that out and you can change them and you can put it back together in an image. So what's happened here is a guy called David DeSandro has basically manipulated an image on the fly by just pixelating it, by just averaging some of the colors in the image and then just drawing shapes. And a little bit more sort of practical use of Canvas, I suppose, is another one by David DeSandro on his portfolio page. And what he does is he basically just has this little line that sort of follows you down the page and sort of highlights key areas of his portfolio. And that was done with Canvas. It was fairly simple, sort of just a little path that just curves around. And it was just a simple Canvas API on top. And just a tiny, tiny little bit of JavaScript did that, no images. And then something I worked on last year with the guys at HTML5 Doctor was, you probably didn't even notice it, but it's this tiny little sort of rollover effect. And it's not an image, but it's also not like a standard sort of shape that you can create with CSS. So that was created by sort of pre-compiling a whole bunch of canvas shapes on the page load and then caching those. So you had this sort of HTML5 Doctor logo shaped rollover for all of these element lists. So Canvas is quite a versatile little tool, even though it's like one of the simplest. So for those who haven't used it, Canvas is quite easy to use. So it's just a simple HTML element, pretty basic. And as long as you provide a width and a height, you're not going to get into any sort of craziness. And then what you can then do is access it using the JavaScript API, which again is pretty simple in itself. And from here, you just access the canvas element in the DOM, and then you access something called the 2D rendering context. Now, I'm not going to go too much into that, and sort of any of the technologies that I'm talking to, I'm not going to go too far. But again, all the sort of details are in here. But the 2D rendering context is more like a window. So the canvas element is more like a window, and the 2D rendering context is like the buildings behind it. So what you're doing is you're reaching through the canvas element, and you're drawing onto that 2D rendering context. And then by calling some of these simple APIs, so like fill style to change the color of the fill of whatever you're drawing, or fill rect to actually draw a filled rectangle or whatever. And you can do arcs, you can do paths, whatever you want. And then what you can then do for in this example would just draw a couple of squares, one with an opaque sort of transparency on it, and another one on top. So you can sort of just get to grips with it. So a little bit more exciting than Canvas is WebGL. Is anyone here using WebGL right now? Okay, that's fairly realistic. It's a pretty specific technology. WebGL is hardware accelerated graphics basically in the browser. So it takes, it's unlike Canvas, but people use it in Canvas-like ways. So games use this to create sort of immersive 3D worlds, like the 3D game I showed you earlier, but they also use it to create hardware accelerated 2D graphics. So for example, the Bejeweled game I showed you, that was using WebGL to sort of create really sort of slick graphical experiences. So one demo of this is a sort of game/demo called Hello Racer, which is really nice sort of example of WebGL being used. Really good textures, really good lighting. It just feels really nice, and it's really good quality actually. I mean, it's nearly console quality, and that's running in real time, and you can just drive it around the browser. And a little bit more practical example of WebGL is something called Tinkercad. So has anyone here tried 3D printing before? Okay. So 3D printing is kind of cool. And Tinkercad is experimenting with something. So it's a little bit like Google SketchUp in the browser. It's like a 3D sort of modeling environment built using WebGL. And what you can then do is, once you've built your model, there's a little button at the top that says Print 3D. And you can actually get that sent off to a 3D printing company, or sort of save the file to your own 3D printer and have that delivered to your doorstep like in the next couple of days. So you've actually built something in the web, and it just comes in its physical form in a couple of days afterwards. There's also sort of game-related versions of sort of demos of WebGL as well. So this is an EVE Online ship viewer. So EVE Online have sort of released a whole bunch of tools on their website that allow you to view the game world in various ways using WebGL. So one of those is this ship viewer, and they've got other ones where you can sort of view the star system and stuff, and you can scroll around and zoom in and see other players. So some of you might have seen this. This is a Nokia Maps WebGL version. Has anyone played on this yet? Okay, that's cool. So Google also did some WebGL stuff, but this goes much, much further. So this is really interesting in that they've sort of like height mapped some of the buildings and stuff. So where Google's quite blocky, this is like really realistic, and even though my internet connection is pretty poor for this, the textures, once they render properly, are absolutely amazing, and they're quite spot on, like the shapes of the building and everything. And it's actually got a 3D view where you can put the glasses on, and it apparently feels quite weird, like flying around these cities. And then my favorite sort of use of WebGL is just to do crazy shit. So this is by a friend of mine called Paul Lewis. He's got a sort of thing for these monkey heads. But yeah, he's really, really good at WebGL, and he just does some crazy stuff, like just making them just do weird stuff. And that's why the technology was created. But I said WebGL was sort of fairly complex, and that's why it wasn't surprising that there were so little people using it. But there's frameworks around that sort of make it much, much more easier to use. So one of these is 3.js by a guy called Mr. Doob. So I'm not going to go into it, but it really lowers the barrier to entry for WebGL. So if you want to get to grips with it and just have a play with it, then definitely check out 3.js. So related to the graphics side of games and animation on the web, there's also something called RequestAnimationFrame. So this has already been mentioned briefly today. RequestAnimationFrame is a new way of doing loops in the browser, particularly animation loops. And previously you would do things like set interval or set timeout. And the problem with that is it spikes the CPU usage. It's not very optimal. So RequestAnimationFrame is basically something that the browsers have implemented to be a little bit more intelligent about how you do animation. So all you do is you request a frame using this API, and when the browser is ready to do that, when it's most optimal, it will update it will call the method that you provide it, and then you can call it again to do the next frame. So this is pretty useful for mobile as well, actually, because you don't want to sort of have something sort of keep running unnecessarily in the background and sort of spike the CPU usage. So RequestAnimationFrame is pretty useful for hardware where you need to be aware of sort of battery level and stuff like that. So RequestAnimationFrame is a pretty simple API. Throughout these demos, I'm just going to be, just to save space, I'm just using the mus prefix for some of the stuff. But for example, in RequestAnimationFrame, there's a really good shim by Paul Irish that basically just allows you to do that cross-browser very simply. So HTML5 Audio is one of the other really cool APIs that are around and particularly useful for games as well. Now, there's the simplistic sort of HTML5 Audio where you just play an audio file. That's great, but that's not what I want to talk about. There's also the audio data API. So at Mozilla, we've got the audio data API, and for WebKit, we've got the web audio API. Well, these are doing fairly similar things. They implement things slightly differently. We're trying to work together to get these sort of consistent. So we're sort of locking the developers away in a room to sort of fight it out. But the idea is that you can access sort of low-level audio data information. So this is really good for games if you want to like load in sound effects and have sort of fine-grained sort of control over what you're doing. You can also create sounds from scratch if you really wanted to. So actually, last year I was at an event in Helsinki to do a sort of demo scene, sort of 3D sort of graphic thing. And I was trying WebGL out, and I tied it to the audio data API. So hopefully I'll be able to play a little demo now. It was basically just this set of cubes, and I'll play it in the background actually. So it's basically a set of cubes that were connected to the audio data, just using JavaScript. And as the audio data changed in real time, particular cubes were attached to those bits of audio data, and they just sort of bounced around. So it was actually a fairly simple API and fairly simple demo to implement. It took like one evening to sort of get to grips with WebGL and to get to grips with the audio data API. And then you just get this sort of real-time visualization. I could scrub the audio back and forth and it would change, and you could plug in any audio file you wanted and it would do something. So this is what it's my sort of favorite demo for sort of showing how you can integrate these technologies so easily because it's all using the same programming language. So a little bit less exciting is local storage, but it's incredibly powerful for games. So previously we'd have to sort of store things sort of in the JavaScript, or you have to use things like cookies. It's a bit weird. So things like local storage, IndexedDB, the application cache and stuff like that are fantastic ways of storing large quantities of data offline. So for gaming, this is really important if you want to sort of jump out of a game and then come back later on. Or, for example, if you're playing on mobile and you've sort of got an experience where your internet connection's intermittent, you don't want to ruin the game experience because the data hasn't been saved anywhere. So I'm not going to go too much into these APIs at all, but it's already been covered actually. So it's just a really good way to sort of keep that experience going, particularly in mobile environments. So one of my favorites actually is WebSockets, and Damon and a whole bunch of others have been talking about this, and it's fantastic technology. So WebSockets has already been really explained, but it's real-time sort of bi-directional communication in the browser, and it's fantastic for multiplayer games. So I already showed you BrowserQuest. So BrowserQuest uses WebGL to do the massively multiplayer communication. So it's basically got a Node.js server running, or a whole bunch of Node.js servers running. And as people join, they set up a WebSockets connection, and they get all the data back and forth for their updates as well as every other player's updates in the game world. And because it's all in real time, you just sort of see all these players walking around. You can chat to them, you can interact with the environment, and everyone's seeing things at the same time. So WebSockets can also be used in a little bit more sort of practical term outside of games. So it's being used a lot for real-time data analytics. So I know Google Analytics have been looking at this recently. There's a company in the UK called GoSquared who are doing some really cool stuff with this. And it's really interesting and slightly creepy how you can follow people around your website now in real time and sort of see what they're doing and what they're looking at, and even chat with them and sort of do weird, funky things. It's kind of cool. So, I mean, you've already seen the implementation of WebSockets, so I won't go over it too much. But it's a very simple API. Like, you've got to set up the server side of things, but even that's not too complicated. So WebSockets is just basically setting up a new socket connection and just sort of, in the WebSockets constructor, just sort of passing that URL to your WebSocket server. And then from there, you can just call the send method, and you can send a text message over to the server, or a binary message if you really want. And that's it. That you've sent a message to the server. And if you want to listen to messages coming back, you just listen to the onMessage event handler, and that's it. And then that's the basics of a multiplayer game. From there, you obviously want to sort of do player positions and stuff like that, but that's really it. So something that I imagine not many people have been playing with yet is web workers. So just to test that, has anyone been using web workers yet? So yeah, barely anyone. Okay. So web workers is really interesting, and it's very, very powerful. It allows you to offload computationally heavy tasks in JavaScript without locking up the browser. So what you do is you basically spawn up these web workers, and you pass them, or you spawn up these web workers as sort of JavaScripts, JavaScript scripts even. And you can sort of allow them to sort of do some sort of computation in the background. And it doesn't lock up the main sort of UI in the browser, so you can sort of carry on doing things. So game developers use this to sort of load up game maps and sort of tons of data at the same time. And then when it's done, it sort of sends a message back to you, and you can sort of pick that up and you can push it back into whatever you're doing. So it's a really sort of specific but a useful way of sort of dealing with large quantities of data in the browser. And like WebSockets, it's got a very simple API. So you just sort of set up a new worker, giving it the script that you've created, and then you just use the APIs that it's got, like post message to send data back out of that script, and just listening to the on message event handler. So something a little bit more interesting, and probably that most of you would find vaguely interesting, is the Fullscreen API. So as I sort of saw earlier, like a few speakers sort of screwing around with the view full screen in the browser. We already have full screen in browsers, and that we can do that. We can make the whole browser full screen, and it makes everything full screen. All the tabs, all the windows, absolutely everything. It just changes the experience for whatever you're doing at that time. So the Fullscreen API is aiming to sort of change that a little bit by allowing you to make a specific element full screen. So if you want to do like a canvas element or a video element, and you just want that to go full screen, and you don't want the entire browser experience to change just for your app, you can do that with the Fullscreen API. And it's actually being used today with video, and you probably haven't even noticed it. So for games, this is really, really good to get an immersive sort of feeling to your game. Instead of having it as a little box in the middle of the web page, you can now have it as a proper sort of interactive, well, immersive experience that you're sort of heavily involved in. And it's a really simple API, as all of them are, really. So you just call the, you just request full screen on a particular element, and that's it. And you'll sort of get a little pop-up saying, like, do you want to give this full screen? And the reason for that sort of security prompt is because if you didn't do that, you could basically force a user's hand, and as they visit a website, you just automatically pop up full screen and show like the Windows background or something, and then start stealing all their passwords, which probably isn't the best idea. And kind of related to full screen is pointer lock. So I don't know if anyone's played like games on the web, maybe in Flash or something, where you've had like a sort of 3D world, or and you need to sort of move the mouse around, and then the mouse hits the edge of the screen, or sort of goes off the edge, and then you have to bring it back and then push it back in again. It's just horrible, horrible experience. So the pointer lock API is aiming to solve that, and it's nothing new. It's just a simple solution to the problem. So what this allows you to do is, when you're in full screen, is lock the cursor to the middle of the screen, hide it, and then what you do is you move the game based on the distance from that middle point. And because the cursor's not there, it's not hitting the sides and moving off the edge and stuff. So you sort of, because it's also in full screen, you sort of really help that immersive experience that I was talking about earlier. And it properly feels like an actual sort of desktop game, rather than sort of this little box in the browser that I keep talking about. So this is actually in, I believe, both in Chrome and Firefox right now, so you can use it. And the same with most of these, actually. There's only one of the things that I'm mentioning today that really isn't sort of fully usable. And the pointer lock API, yeah, again, is just as easy as the full screen API. Once you're in full screen, you just request the pointer lock, and that's it. They might get a prompt if they haven't already, but that's it, and then you just lock the screen. And if they come to the game again, they don't get any of those prompts, because you can remember that. So one of my favorites, and probably the favorite actually, is the Gamepad API. So this is one of the major improvements with input that's coming in browsers, and this is the one that's not fully supported yet. So Mozilla and Google are working on this together, which is fantastic. And we sort of created this in about 3 months, and it was quite cool to see how fast this was done. And what I find most interesting about the Gamepad API is it's probably one of the APIs on top of these device APIs that you heard about earlier that's really going to sort of start justifying the web as a platform. So I can just imagine this being used, like if you had a browser environment on a TV, for example, like a decent browser environment. If you had the Gamepad API and you're just playing like sort of arcade-style games, like Xbox Arcade or sort of web-based kind of games, you wouldn't necessarily need a console anymore. If you can connect your Gamepad in and get that sort of Gamepad experience with the full screen and all that kind of stuff, when you combine all these APIs together, you can really sort of see how interesting this might be. So I just want to quickly demo the Gamepad API while I'm here. Just move over that. So I've got a Gamepad plugged into my laptop. Nothing special, just a USB Gamepad. and I can move it around. And this is just using JavaScript. So it's pretty interesting. Like the API isn't that complicated. I'll run through it quickly in a moment. But I think this was the first time I realized like how exciting game development could become on the web right now. Because there's a few sort of roadblocks. One of these is audio, and we're trying to solve that. One of these is input as well. We're used to this sort of keyboard and mouse input with games on desktop, and that's fine, but HTML5 is sort of cross-platform. So once it gets into these environments like TVs and consoles, we're going to need sort of support like this. So it was really interesting to see both Google and Firefox sort of jumping on this. So it's really cool, and I advise you to check it out if you're playing, sort of creating games. So yeah, just another quick demo, just in case that didn't work as well. This is basically Rawkits, which is a little game experiment that I made, which is currently broken. I know some people were tweeting about it, and then Damon was talking about it. But I was trying the Gamepad API in this just to actually see what it was like, and also just to learn how to use it. And this was when I truly got how different a game feels in JavaScript when you change sort of the input and sort of use the same kind of input you get in those console environments. And it really does change the game. It actually feels like a proper game, even though it looks pretty crap. And it works both in Google and Chrome and Firefox, so I won't go through the whole video because it's kind of long. But the Gamepad API, yeah, you just listen to basic events. So you just listen to a connection event, and you just grab a reference to the Gamepad object. And then once you've got that, you can basically poll that Gamepad object and request to sort of get the state of the buttons and the axis movement, the joysticks and trigger movements and stuff like that. And the API supports like anything that's recognized as a operating system gamepad. So PS3 controllers work, Xbox controllers work, so that's including Bluetooth. Logitech controllers, you can have an old sort of USB joystick if you really want. So this isn't specific to anything, it's a device API, it's kind of interesting. So yeah, I definitely advise you checking that out because it really does change the way you play games. It really changed the way I was developing mine. So if anyone's done mobile development, you probably bumped into the whole screen orientation issue. So if you're developing in the browser and on mobile, what happens is unless the user's locked the entire operating system orientation, you're going to sort of have this problem where things start flipping around and do some crazy stuff. The orientation API basically allows you to, when in full screen, it allows you to lock to a particular orientation with one line of code. So what this allows you to do is, like, for example, if you have a full screen game or a web app or something, you can know that it's going to look and feel like it should do because it's locked into its landscape orientation or portrait, whatever you want. And that really does change the way the apps feel as well on mobile. They don't feel kind of clunky, they actually feel like they should be doing what they're doing. So it's the same experience that you get on iOS. And like, as I said, it's a one-line sort of piece of code. So once you've gone into full screen, you just access the screen object in the browser, and then just call the lock orientation method with the orientation that you want. It's pretty simple. So aside from these in-browser technologies, and we've mentioned this one sort of extensively throughout the day, so I really won't cover this, but Node.js is fantastic for game development if you want to do multiplayer stuff, or even if you're just serving those game files and stuff. So the Express framework and stuff like that is fantastic for serving game files quickly. But also libraries like Socket.io for WebSocket communication is also really, really good. So something that's kind of interesting that's not really been covered much yet is web applications. And how do you monetize these games and all that kind of stuff? Where do you distribute them? So web applications is something that we're sort of looking at quite a lot at Mozilla right now. And I know Google are looking at this as well. Facebook too. There's a whole bunch of people looking at this because it's a pretty big thing, particularly on the web, because we don't really have these distribution platforms sorted yet. So one of these, the idea of this sort of open web app sort of ecosystem is that it puts developers back in control of distribution and development and sort of how they communicate with their users. So yeah, we're working on this marketplace, but what I wanted to cover more is the app-like experience that we're developing around this. So some of the APIs that we're bringing to the web, to the browsers to allow your games, your applications to feel sort of like proper applications, like rich experiences. So one of these ways is looking at how to completely remove the browser UI. So if anyone's used anything like Fluid or other sort of applications to sort of make a web app or a website look like a native app, this is exactly what we're doing. So we call this WebRT, which stands for Web Runtime. And by us, that's Mozilla right now. The idea is to standardize this, as everything is at Mozilla. But it's a built-in API into the browser that when you install a web app, and a web app is just a website with a special JSON file, it installs it natively into the operating system. So this goes into wherever applications go on Windows. I don't use Windows. But on Mac, it would go into the applications folder, and you can drag that to the dock. It's a .app file. It looks and feels like an application. It's got an icon that's described in that JSON file I was talking about. And when you launch it, it launches as a native application. It looks like a native application. It's got no browser UI. It doesn't feel like you're sort of in this glorified website. It actually feels like you're in a proper application. So yeah, this is just an example of a game called Sinuous by a guy called Hakim Al-Hattab, which is, I just installed that directly off the Mozilla Marketplace. But you can install these games directly off your own website if you really wanted to. So if you haven't already sort of tried game development in HTML5, I probably should have asked this earlier actually. Has anyone developed a game with HTML5 yet? Okay. Like, barely any of you. So, I mean, hopefully I've inspired a sort of a few of you to try this. But if you haven't already tried HTML5 game development, then I advise you to really just give it a go. There's a few libraries out there or frameworks that ease this process. So if you don't really want to learn like the nitty-gritty, and you just want to make a game and have some fun, there's a good one called Impact, which is not completely free. I think it's $99, but it's one of the best. It's got fantastic documentation. The author is active. He's very friendly. He's always on IRC, happy to help. And it's one of the best. It's just very polished. So definitely check this one out. Being used right now for sort of side-scrolling games, but you could use it for other games if you really wanted to. Another one that's free, and I believe by an Australian author, is Crafty. So Crafty, documentation's not quite as good, but it's still a fantastic game engine. So I definitely advise checking that out if you're just interested in having a quick hack on a free game engine. And there's also one if you really want to make like Farmville kind of games, and I feel sorry for you if you do, but if you want to make that sort of Command & Conquer style game, then you can use something like Isogenic Engine. So Isogenic Engine is a 2.5D sort of entire sort of game engine stack. And it has like a node-based server, so it can do the whole multiplayer stuff built in. And then you've got the whole sort of canvas front end. And this guy's really, really gone all out with this. It performs amazingly on all platforms. And if you don't necessarily want to create games in JavaScript, like I was talking to a few people over the last few days, and some people are sort of developing in Java, or they've already got stuff developed in like C++. That's not a problem. Like, there's no problem with sort of doing that. You can now convert and port over to JavaScript in ways that sort of you weren't able to do before, and have it work as well as it could. So one of these is MScript, and this is actually a Mozilla project. MScript is really interesting. So you can basically port over C++ code and have it convert over to JavaScript. And it doesn't look human readable at all, because it's done probably in the way that JavaScript runs fastest. So you're not sort of formatting it properly and all that kind of stuff. So it's definitely not sort of probably readable to a few of you, but to the average developer, probably not. So MScript is quite interesting. A lot of people have been using it to port things as demos, port things like Ruby and Django. Why? I have no idea, but they did it. It's completely possible. But the useful side of things is they're porting things like physics engines, like Box2D, which is what Angry Birds is based on. And if you want to use like Java as a sort of single code base, and then you want to have that port out to things like JavaScript, Android, Flash, that kind of stuff, you can use things like Google's PlayN. So the Quake demo I showed you earlier was based on the predecessor to PlayN. And then sort of the flip side, if you want to sort of take JavaScript, you really do want to develop in JavaScript, but you want to push that out to native environments like iOS and Android, that kind of stuff, then use things like PhoneGap. It's absolutely fantastic for those kind of situations. So I've covered a fair amount of technologies, definitely not all of them. So I definitely advise you to sort of check out some of the documentation and the resources to sort of see the other ones that are available. So one of these is the Are We Fun Yet page on Mozilla. So this is basically just documenting absolutely everything that we're working on for games and sort of animation and that kind of stuff. So particularly some of the performance-related things, so with the garbage collection improvements that we're making in JavaScript, and some of the improvements we're making with graphics and Gamepad, all that kind of stuff. So definitely check out that page. There's also something which we call Are We Mobile Yet, probably see the theme there. And boot to Gecko. So boot to Gecko was mentioned briefly, is a mobile phone sort of operating system that we're creating basically just out of JavaScript and HTML. I actually have one of the devices with me here, so if you guys want to sort of see a demo of that later, like in the evening, then definitely grab me and I'll show you, happily show you that. But what's interesting with this is the device APIs that we're sort of creating outside of it, and how those apply to games. So if you want to see how those are going and which ones are coming in the future, then definitely check out those two websites. Links are in slides, obviously. If you want to actually get hands-on with this kind of stuff, I advise you to check out the development versions of the browsers. So Chrome's obviously got its development channels as well. Firefox does too. Firefox Aurora is probably the point at which you can be comfortable that something's going to be supported in the browser. So this is probably about sort of 12 weeks, or about 12 weeks before a feature is going to land in the public version of Firefox. So if it's in Aurora, then you can sort of pretty much get ready to use it and start experimenting with it. If you really want to live on the edge, then there's Firefox Nightly. So Firefox Nightly is basically, as it says, updated every night with all of the crazy stuff that we're working on. So the Gamepad API is going to be landing in that soon, properly. All of the sort of other improvements that we're making with garbage collection and stuff like that land in Firefox Nightly first. Don't use this as an expected sort of, oh, this kind of stuff will come in the next few weeks. It's potentially something that will roll back out or roll back in as time goes by and we sort of learn from people using it. But definitely try it out if you want to get to see and play with some of the technologies that are coming. So just before I finish, I'd like to sort of talk about a few things to bear in mind regarding HTML5 game development. So one of these is HTML5 isn't magic as much as people say it is. It cannot and shouldn't do everything. So there seems to be a lot of buzz around the technology stack about how it's the technology to do absolutely everything with. This thinking is just wrong, right? So just because games can be made with HTML5 and JavaScript, it doesn't mean that all types of games should be made with those technologies. It's just not right. So it can be the case that HTML5 and JavaScript might not be the best platform for your game. Like, that's not a problem. So you just got to be realistic. The other thing is create games for the web, right? So right now, we tend to be looking at games on the web by comparing them to other platforms. So we're seeing a lot of games being ported from iOS and consoles and that kind of stuff, which is great. It gets to prove the platform, and you don't sort of have to create a new game from scratch. But what we're doing is we're setting up sort of things to fail, because the web isn't the same as these other platforms, which is kind of obvious. But we shouldn't try and replicate what these other platforms are doing. So this fails because we just end up constantly sort of comparing the web port of this game to the native version. And of course, the native version is going to sort of be better looking and sort of faster because it was developed for a different platform. So this isn't, the web doesn't look inferior because it's crap. The web looks inferior in these situations because we can't replicate those sort of situations from the native technologies all the time, right? So it's just unfair to compare them in that way, basically, is what I'm trying to say. Yeah, so the other thing is that by doing this, you're actively limiting the capabilities of the games that you're creating. So if you're constantly trying to sort of strive to replicate like iOS environment or a console environment, you're not using the web for what the web could be used for. So the web obviously is much more open. Like, you can connect to all these different APIs, and you don't have to be stuck in this tiny little box on the screen. The game could be across the entire website. It could be the website. It could be across multiple web pages. It could be on Twitter. It could be wherever you want. Like, this is the kind of stuff I'd love to see, is games that aren't just replicating what we've already seen with games, this tiny little box that you can't really do much with. But the big thing I'd love to see is embracing the limitations of devices. Right now, sort of coupled with the first point I said, HTML5 is seen as this magic technology, and it's seen as this technology that sort of works the same across every single device because it could be supported by all these devices. Well, that's great, and yeah, you could kind of make something look similar on all the devices. But say you had a Battlefield 3 WebGL version with like I don't know, WebSockets or real-time multiplayer. So you've got this nice desktop version that's running absolutely fantastic. Should it be even playable on other devices? And if so, should it look and feel the same as the desktop version? So my opinion is that it should work on those platforms, but it shouldn't look and feel the same. And that's pretty obvious, but it's not happening. So this is, I mean, purely just down to like things like hardware performance. Like, you shouldn't think that bleeding edge sort of HTML5 games on a desktop should play the same on mobile hardware. I mean, you don't expect this from other platforms, so why HTML5, right? So, and even if it could run really well on like a mobile device, would it be the best experience? Because things like screen size and input methods are just going to completely ruin it. You're going to have fonts all over the screen. It's just going to be ridiculous. So if you imagine you're playing that HTML5 Battlefield 3, you have that full screen experience. It's really immersive. You're having good fun. You've got the complex mouse and keyboard controls, or Gamepad if you really wanted to. So it's just like any native desktop first-person shooter, right? So your friends are also playing in this game via WebSockets. And you can see them running around in the game world. And now imagine you have to leave the house. Oh, crap. That's not good. I thought the plug was on. That doesn't help. Anyway, okay, yeah, that's cool. Thank you. So, you've got this immersive sort of 3D environment on your desktop, WebGL, WebSockets, all that kind of stuff. You're running around this 3D environment. So imagine you need to leave the house, which might not happen that much, but say you need to leave the house and you don't want to stop playing the game, which probably would happen. So on your way out the door, you close down your desktop, or you put it to sleep if you're like me, just to leave like tweets coming in and stuff like that. And you open up Battlefield 3 HTML5 on your mobile phone, right? But instead of trying to replicate that epic immersive experience that you were having before and having it look really crap and just being unplayable, you can jump into a mobile optimized version of the game. So in this version of the game, you're still using WebSockets, you're still connecting to the same game server. It's still the same game that your friends are playing. They're still running around having fun, and you don't get those intense 3D graphics that you did, and you don't have a complex control system. But now you have like a 2D bird's eye view of the game world with much simpler controls that fit the device that you're playing on. So in this view, you can see like little green dots sort of running around the game, which are your friends, and little red dots, which are your enemies running around as well, which they can't see yet, but you can. So from here, you can basically act as the commander of like this game of your team. So you're still involved in the gameplay, but it's a completely different experience. And you're playing to the strengths of the device that you're currently on. So, for example, you could click on each of your teammates, and you could sort of have this little sort of message head-up display come up, sort of send them sort of messages saying the enemy's over here and stuff like that, and it would show up in their sort of rich 3D version of the game. Or you could sort of point out enemies, and it would sort of show a little waypoint on the 3D version of the game as well. Or call in an airstrike on a particular part of the map, and that happens in the 3D version of the game too. And all of this while just sitting on the bus. Like, you don't need that rich environment to still get involved and have fun with that game. So my point here is that you're still able to take part in that world that you were previously sort of involved in, but you don't have to sort of try and replicate and strive for that experience or that version of the game that sort of people keep telling you should be doing. So the basic way I look at this is you basically just view the devices as windows into these game worlds. So I'll leave it there. So I hope I've managed to at least pique your interest a little bit. Definitely try out things like the Gamepad API. It's absolutely fantastic. So if you want to go out and play, create some of these games, I definitely advise you to do that. And even if you don't want to make a full game, I advise you to sort of check out some of the specific APIs. Because it's absolutely fantastic what some of them are doing and how they integrate together. So I basically want to just end it by saying the future's pretty bright for games on the web. And I'm really excited to see what comes in the next few months and year. So I've been Rob Hawks. I'm at Rob Hawks on Twitter if you want to bug me and just sort of listen to me whine. Rorks.com is my blog, is where I sort of whine in more detail. The slides will go up on SlideShare after this. I'll put them up on slideshare.net/RobHawks. So just search Rob Hawks and you'll find it. But yeah, thank you very much for listening.